Sensors are the way a robot discovers the world and understands it. There are literally thousands of different types. I just want to go through a few. There's touch, temperature, essential if you're going into burning buildings. Vision, being able to see and then work out what you're seeing. Sound, being able to hear, and robots can hear incredibly small sounds. Energy, working out how much energy the robot is using so you can determine whether it's going uphill. You can also measure distance, which is essential for navigation. If you're picking things up, you'll want to know weight. Sometimes it's useful to know whether it's going to rain, and you do that through humidity sensors. Color, conductivity. The conductivity is used to determine whether something is metal or not non-metal. X-rays, very useful for penetrating through objects and being able to see what is behind an object, behind a wall. And smoke, well, that could be very useful in a fire situation. Now, what we have to do is we have to understand the input and output model. And let us first consider a human being. So at the heart of a human being is a thinking brain. The brain receives inputs from the senses: taste, sight, hearing, touch, and smell. It then thinks about what reaction it should do, and it sends out signals to the myriad of muscles in the human body. It might tense the arm, you might start running, or you might operate one of the thousands of muscles in the human body. A robot has inputs and outputs as well. Its brain is a microchip and circuit board. It has inputs, and the inputs are our senses like touch, vision, distance, sound. And it has outputs. And the outputs this time are essentially driven by motors. So you get robotic legs and arms. Another host of things you can do is you can get cutting tools, and you can get lasers, and you can get lights, and you can even get telephones in a robot. So there are a whole range of outputs. I just want to talk a little bit about the simplest form of sensor, which is a touch sensor, which can be made using a switch. Electricity cannot bridge the gap where you can see the switch unless it's pushed shut by the robot touching something. When it does that, the electricity can all the way around, and in this case go to the brain, not the light bulb. So it's a very simple way, and you can change the pressure that the switch needs to close, and that way you get different qualities of touch. Distance is essential for navigation, and it's really important to understand distance in robotics. It's very, very similar to a bat. A bat emits loads of high-pitched squeals, effectively, and they radiate out like waves until they hit an object. When they hit an object, it bounces back, as you can see here. It's bouncing back to the bat, and the bat then receives the signal back, and it works out how long it took to get back, and that tells it how far away it is. It's called echolocation, and it works brilliantly. Dolphins, whales all use it, and they don't bump into things. So that's a little gallop through the world of sensors. Now you have to apply some of this thinking to your design of a robot. Thank you.